Good afternoon, and welcome to Hand-Wavy Chemistry, where we do not delight in the detail, but rather bask in the big picture. Today, I have something very unfortunate to tell you. Your chemistry teacher has been lying to you. And this lie isn't new. My chemistry teacher lied to me, and I've lied to others in the past as well. And this lie is to do with nomenclature, the naming of chemicals. There is an anecdote, often repeated, about politicians wanting to ban dihydrogen monoxide. And the punchline is always, dihydrogen monoxide is the proper name for water. I found this weird when I first heard it because when I was a student, I was told that hydrogen oxide was the proper name for water. And if we look on Wikipedia, we'll find a whole slew of different names suggested for water. And on this list, we will see hydrogen oxide and dihydrogen monoxide. We'll also see hydrogen hydroxide, dihydrogen oxide, hydroxyic acid, and up at the top, we see two entries that are separate to the others. These entries have IUPAC written on them. One of them says IUPAC systemic name, which is oxidane, and the other says IUPAC name, which is water. So, who is this IUPAC, and why are their entries separate? IUPAC is the International Union of Pure and Applied Chemistry. They're like the governing body of chemistry. They publish multiple books related to chemical communication. They give out guidelines for how to write units, how to do correct grammar when writing out a scientific paper, and they also put out books related to the naming of chemicals. The name of IUPAC is also often used when your teacher is trying to lie to you a little. They'll tell you that this is the official IUPAC name. If we look at the Texas Educational Standards, their TEKS, we will find that Chemistry TEK 12A says that students will write and name acids and bases according to IUPAC nomenclature rules. However, I guarantee you that no school in Texas actually teaches the IUPAC nomenclature rules. There is no school out there telling you that nitric acid is hydroxido dioxido nitrogen. Also, another quick test to figure out if your school is following IUPAC naming rules. What do they call HCl? Almost certainly they call it hydrochloric acid. However, in the Red Book, which is IUPAC's guide to writing and naming inorganic compounds, it says, names which do not denote compounds of a definite composition, such as hydrochloric acid, stannic acid, tungstic acid, etc., are outside the scope of the systematic nomenclature presented here. However, the chemical systems involved can always be discussed using systemic names such as hydrogen chloride, tin 4 oxide, tungsten 6 oxide, etc. And in their publication, The Principles of Chemical Nomenclature, they refer to hydrochloric acid as being a trivial or common name for an aqueous solution of hydrogen chloride. Adding to the confusion is if you were to type into Google, what is the IUPAC name for HCl? The answer comes back first from their generative AI saying chlorane. However, if you scroll down a little, you will find many resources telling you that the official IUPAC name for HCl is hydrochloric acid. So where is this confusion coming from? Why are we getting conflicting answers and different names? The conflict arises from different goals, different reasons communicating ideas. In the start of the Red Book, it says the following: "The primary aim of a chemical nomenclature is to provide methodology for assigning descriptors, names, and formulae to chemical species so that they can be identified without ambiguity, thereby facilitating communication. A subsidiary aim is to achieve standardization, although this need not be so absolute as to require only one name for a substance. The number of acceptable names needs to be minimized." However, in the chemistry classroom, your teacher needs a way to generate grades, scores. And so by teaching an arbitrary naming system, just picking out one of them, they can examine that one. But rather than asking an honest question, which would be, according to the naming conventions that I taught you, what would you call this? They go for something that sounds more authoritative. What is the proper name for this chemical? So, how is it possible for water to have so many names? For hydrochloric acid to also be hydrogen chloride or chlorane? This comes down to the way that chemical names can be produced. One option is a historical name, a name that has been used for so long that it is just synonymous with that chemical. This is why we call water water. Everybody understands what water is. Using a name like dihydrogen monoxide creates confusion. Although you could argue it is more precise than saying water, it confuses others and therefore isn't really the best choice. Another example of this is for acetic acid. Acetic acid is not the systematic name. That would be ethanoic acid. However, IUPAC recognize that it has been called acetic acid for so long that it makes sense to have that be the preferred name. For the hydrochloric acids example, the chlorane, or when we had water we said oxidane, that is a substitutive naming system. It's based around the ideas from organic chemistry, where we have something like methane, which was CH4. So if we take out that carbon, we put something else in there. If it was oxygen, it became oxidane. If it was boron, it would be borane. If it's chlorine, it's chlorane. It's just another systematic way to generate a name. And finally, I mentioned earlier that nitric acid could also be known as hydroxidodioxidonitrogen. Well, this is an additive naming system, whereby I'm talking about what kind of groups are attached to that nitrogen. And there's a hydroxide group and two oxide groups, hence hydroxidodioxidonitrogen. Something else that is often overlooked is the full titles for the Red and Blue Book. The Red Book is the Nomenclature of Inorganic Chemistry, IUPAC Recommendations. And the Blue Book is the Nomenclature of Organic Chemistry, IUPAC Recommendations. These books are recommendations and guidelines. So, what are my recommendations? Use the name that makes the most sense in the context. If you are working in a field where chemicals are regularly referred to by a particular certain name, even if it's not the most systematic name, by all means, keep using that word. It is important that you are understood, especially if you're trying to communicate that there is a hazard or there is a problem. However, if clarity is important, if letting people know exactly what the chemical is matters more so than having a quick, snappy name for it, then use a naming convention that is unambiguous, that will generate an exact species. Or another option is to just draw out the chemical. And this is done by scientists all the time. It is very common in scientific literature for, rather than just giving the name of a chemical, a picture of the chemical is shown and it is assigned a number. This is going to be chemical number 1. And throughout that paper, they'll just refer back to chemical number 1. Please understand that this discussion on nomenclature is in no way exhaustive of all the different naming conventions and systems. We have hardly even touched on any of the organic naming conventions. But that is a story for another time. I hope you have enjoyed this video, and if you have, please make sure to click like and subscribe and share it with your friends. And if you would like to contribute anything to this discussion or suggest a topic for a future video, please put it in the comment section below. Thank you, and I hope you have a wonderful rest of your day.